Assalamu alaikum. I am Anis Ahmed. Today I will discuss Routh stability criteria. So the learning outcome of this course is at the end of the course, student will be able to determine system stability from mathematical model. So what is the concept of stability? The concept of stability is well understood by this picture. This material is stable. That means a large excitation is needed to change its state, and this is in neutral in position. It's also called marginally stable. And the last picture demonstrates the unstable condition. It indicates that a small excitation can change its state. So from this picture, we can say the stable is the state of being firmly fixed or not likely to move or change is called stable condition. So we can say a stable system is a dynamic system with bounded response to a bounded input. What is bounded response? The bounded response is like this. This is, say for example, this is boundary. So response should be in boundary. So what is instability? If it's cross the boundary level. That means if a response is increasing in manner with passage of time like this, so its cost crosses the boundary. So we can say this response is unstable. This response demonstrates the unstable condition. So the stability can be shown on the S-plane. How? The left half of S-plane is demonstrates stable condition, and it's well understood by this graph. This is decreasing in manner. So this is stable condition, and the marginal stable condition, that's mean neutral stable, is demonstrated by this picture. And the finally unstable condition is can be found by this picture, which indicates that the output is increasing with the passage of time. So how this picture can be drawn? So for this we have to understand what is characteristics equation and what is transfer function. So we can say a necessary and sufficient condition for feedback system to be stable is that all poles of the system transfer function have negative real parts. For this we have to first determine the system transfer function. The system transfer function actually is a control ratio of closed loop gain. This is found by this formula, and the denominator of this transfer function, that is 1 plus minus GS, indicates the characteristics equation. From the characteristics equation we can found some root that indicates the system pole, and these system poles can be put here, and by this we can determine the system stability. So let's see how this actually form. So this actually can be found by Routh-Hurwitz stability criteria test. For doing this we have two steps. The step number one is, in order to test system stability, first construct the Routh array from the system characteristics equation. So system characteristics equation actually found from the closed loop transfer function, and from the closed loop transfer function the system characteristics equation is given by this formula. From this we can construct the Routh array by this manner, where the highest power of s is s to the power n, has a coefficient of bn, this is here, and after jumping on term, next term coefficient is bn minus 2, and another term comes from this like this manner, and the s to the power n minus 1 has a coefficient of bn minus 1, and another remaining term comes from the similar manner. So from this two row we have to determine the remaining rows. This is this and remaining. So how to find C1? the C1 can be found as this term will be multiplied by this term and minus multiplication of these two terms, and finally the result will be divided by this term, and finally we will get the C1, which is coefficient, first coefficient of Sn minus 2. So what is will be the coefficient of Sn minus 4? This is C2. This also can be found like this manner. This means this term is multiplied by this term and minus this term multiplied by this term, and the result will be divided by this term, and other coefficient is found by this similar fashion. So let's see an example which will shows that this is the example. So this is the characteristic equation that is found from the closed loop transfer function gain. From this we have to consider the Routh array. So the Routh array is formed here from the previous slide, this formula, from this formula. So the coefficient of highest power of here, the highest power is s to the power 5, which is here, and the coefficient of s to the power 5 is 1. The next coefficient is 10, next is 152, and next power is s to the power 4, has a coefficient of 1, next is 72, and last is 240. So from this we have to determine the coefficient of s to the power 3 and many more terms. So how to calculate here s to the power 3? The s to the power 3 here comes from 1 multiplied by 10 minus 1 multiplied by 72 divided by 1, and this gives us minus 62, and minus 82 is comes this term multiplied by this term minus this term multiplied by this term, and the resultant will be divided by this term, and this gives us minus 88, and other values are calculated by similar fashion. So what was the step number 2 of Routh's criteria? This states that the number of change in sign in the of the first column of the Routh array is equal to the number of poles in the right half S-plane. So here we can see that two sign changes. One is 1 to minus 62. This is one sign change, and minus 62 to 70.6. This is another sign change. So here we can say that two sign change means two poles are exist in the right half S-plane. So we can say in this portion we have two poles, and we previously said that right half S-plane indicates system instability. So we can conclude that our system that is given by this characteristics equation is unstable. Why? It has two poles exist in the right half S-plane. So this system is unstable. Thank you for your patience.